Hi, good morning, everyone. Morning, I see people coming in. I have the Q&A open, so please do let me know if you can hear me loud and clear. Hi, Kevin. Thank you, and good morning. Great, I'm gonna stop my video and I'm gonna start the webinar once we have a few more people in. Let me share my screen. Okay, let's start. So again, everybody who has just joined, good morning. Today, our webinar is on the use of aeronautical engineering in infrastructure and construction. And in particular, we're going to be focusing on drones. To add, this is also a main focus by UNESCO in support of the Sustainable Development Goal 9. Now, why are we looking at Goal 9? We're looking at Goal 9 in terms of how technology can help infrastructure and construction. This event is supported by UNESCO and Empire Code LASPEC as a part of the Fostering and Enhancing Synergies among science networks in Asia and the Pacific. Engineering's contribution to SDG Goal 9 and 17. Now, this webinar is going to be interactive. So for all you participants that are online, please feel free to use the Q&A function that's on the webinar chat room. I'm your host. My name is Jasmine. I am one of the founders of Empire Code LoveSpec, a social enterprise as part of the Empire Code Group. The Empire Code Group of companies includes computer science education and software development. Now, a little bit about myself. I am an aerospace aeronautical engineer by trade. I graduated from the University of Glasgow in 2001. I started my career at Singapore Technologies Aerospace. Now, when I was at Singapore Technologies Aerospace, I was working on fighter jet upgrades, and in particular, converting fighter jets to reconnaissance aircraft. Alongside that, my experience is in aircraft fluid dynamics, where I look at vortex flows over wings, in particular fixed-wing aircraft. I'm also trained as a structural engineer, where I look at how the aircraft structure works and work in terms of the engineering of cuts and holes on aircraft. So say you're going to put in a camera on an aircraft, or you're going to do something different, and you're going to restructure the aircraft. I look at whether the aircraft is structurally fit to fly again based on any changes that are to be made. Now, at this point in time, I head up Empire Code Launchpad, which is the technology arm of Empire Code. Empire Code Launchpad is our software development arm. We do customized software development across various industries, including medical, healthcare, medical healthcare. We do education. We also look at gamification apps. We look at all kinds of things, booking apps as well. Now, what will we cover during this webinar? We'll be looking at the introduction to SDGs. We're looking at drones, the use of drones for SDG Goal 9. We'll look at some case studies, research and development, the law. We'll interact with each other, and then we'll look at some additional learning resources that you can take away as well with you today. Now, like I said, this webinar is interactive, and I would like for you to ask any questions along the way. And as and when I can, I'll stop to answer your questions as well. So feel free to use the Q&A. Now let's start. Introduction to SDG, or rather Sustainable Development Goals. The Sustainable Development Goals are a call for action by all countries, poor, rich, and middle income, to promote prosperity while protecting the planet. Now, recently, we did another project with UNESCO where we looked at how fashion, and in particular, how the manufacturing of fashion can help the planet as well. So the use of dyes that are not chemical dyes, like chemical dyes that can harm our environment, ensuring that waste, when the clothing gets thrown away, it doesn't affect our environment. There are just so many ways of protecting our planet. We recognize that ending poverty must go hand in hand with strategies that build economic growth and address a range of social needs, including education, health, social protection, and job opportunities. The main thing that we're trying to tackle is climate change and environmental protection. Most importantly, the goals provide a critical framework for the COVID-19 recovery. Now, if you want to understand more about sustainable goals, please you can go to this website in the UN.org, and there's a link on sustainable development. Now, that is extremely helpful in terms of understanding all of how sustainable development works. Please note that this webinar is being recorded, and if you ever want to come back and understand a bit more, you're more than welcome to do so. Now, our focus goal for the day will be on Goal 9, Industries, Innovation, and Infrastructure. Innovation and technological progress are key to finding lasting solutions to both economic and environmental changes, such as increased resource and energy efficiency. Now, globally, investment in R&D as a proportion of GDP, which is gross domestic product, increased from 1.5% in 2000 to 1.7% in 2015. It's remained unchanged since 2017. Now, this has got to change in particular because the world is not spending enough R&D in terms of protecting climate change and in any kinds of innovation that can help infrastructure as well. We need to figure out how to increase in these developing nations in particular. Now, developing nations tend to suffer the most, of course. Developing nations need all the help that they can get in terms of R&D and how design can be cheapened as well. Now, together with this, we're not, as part of Goal 9, we don't only look at innovation and structure, we also look at manufacturing industries. We look at how most of the world is still covered by the 2G network. So that is considered communications infrastructure, and that also affects how infrastructure works. Now, the coronavirus pandemic has revealed the urgent need for us for more resilient infrastructure. The Asian Development Bank notes that critical infrastructure in the region remains far from adequate in many countries. Now, this has got to change, as I mentioned, and we're looking at how we can educate people through webinars like this to get more involved in R&D, and in particular for Goal 9 today. Now, we can encourage more people to do more R&D. It means that we can cheapen the cost of manufacturing, because if there's only one particular design that can make a change to infrastructure, that design will be very costly with no competition. If we can get more R&D and more competition, everything will cheapen. So here it is again. Here's a link here that you can look at as well. The source is at the UN.org, and in particular, when you go into the UN.org website, you can see all the goals and you can select in particular that goal that you are after. Now, a few definitions here to help us with the webinar. Industries are a group of manufacturers or businesses that produce a particular kind of goods and services. For example, clothes manufacturing industries. You can also include any industries that come into play, like industries that manufacture furniture, industries that even manufacture medical parts, medical engineering, they're all part of it. Now, innovation is the action or process of making changes in something that is already there. So it's not about coming up with new R&D, or it's not, this in particular, the word innovation doesn't mean you have to invent something or you have to design something new. The idea of innovation is being able to introduce new methods. So you have a design idea and you do it better, or maybe you just change it or you make it cheaper. But this innovation can fall under R&D as an included process to enhance things. Third, we have infrastructure, which is the physical structures and facilities. For example, your buildings, your roads, your power supplies, your train lines, your airports needed for the operation of a society or enterprise. So back in the old days, if you go back to the 1700s or the 1800s, and we had to move coal from one part of the US to another part of the US, what would have to happen? They probably started moving coal by horses. So they go on horseback and they move coal, and they let the horses move it. Of course, it takes days, weeks, potentially for things to travel from one part of the country to just within a state, or not even within a state. Within a state, it probably took weeks. But don't even talk about within the country. So you need infrastructure like shipping docks. So you need shipping docks to move things within a country. But of course, the train line changed everything. And the train line, like technology, was a disruptive tool of infrastructure as well. the train line changed things, and the train line enabled coal to move across many states in much quicker ways. So when you think about R&D, don't only think about creating one new design. Let's say in this focus of our topic today is on drones. You don't think about creating new drones only. You can think about all the other ways that you can innovate, or other ways that you can change to help infrastructure to move new designs across countries and worlds much more easily. Now, why should we care? Inclusive and sustainable industrialization, together with innovation and infrastructure, can make things more competitive, like I said before. But not only that, not only does it cheapen the cost for developing countries to buy new manufacturing ideas or to implement infrastructure, it can generate employment and income. Because the main idea is you want to ensure that everybody can support their families and everyone is able to put food on the table. Now, this can only be done if everyone is employed with an income. So Goal 9 matters in introducing and promoting new technologies, facilitating international trade, and enabling our developing nations to find employment. The growth of new industries means improvement in standard of living for many of us, and this will have a much different impact. In particular, COVID-19 has showed us how many people have suffered in terms of unemployment from home, in terms of losing their jobs. In Indonesia, for example, we are aware of plenty of drivers, whether it's Gojek or Grab drivers, which is their flagship car hailing apps. Now, these drivers that work for Gojek, for example, have lost their jobs. And it is tough, but it doesn't mean we stop and wait for the pandemic to be over. We need to keep thinking of many ways to keep people employed and how we can enable inclusive and sustainable industrialization. So there's more information here on the link on why it matters, and I encourage you to take a look at that as well. Now, why aeronautical engineering? So we'll come to this. Now, what is aeronautical engineering? It's a branch of engineering that deals with design, development, testing, and production of aircraft and related systems. Now, when we talk about related systems, we don't only talk about aircraft that fly you from Vietnam to Thailand. No, we talk about aeronautical as a whole scope. Aeronautical engineers develop and design technologies including supersonic jets, helicopters, space shuttles, satellites, and rockets. Aeronautical engineers design, develop, test, and help manufacture commercial and military aircraft. Missiles also fall under the aeronautical engineering space. Spacecraft is also part of aeronautical engineering. There are a bulk of aeronautical engineers working for Tesla even. Now, there are a bulk of aeronautical engineers working for SpaceX. Now, you might wonder what Tesla has to do with SpaceX. SpaceX is all design. So SpaceX would be the aeronautical engineering side of bringing people to space. So how do we design better spacecraft? How do we ensure that the spacecraft can go to Mars perhaps and come back? Now, in terms of Tesla, you might think it's car design, but what does it have to do with it? You may not know, but even Formula One takes a lot of the aeronautical engineering techniques into their car design. Now, this includes how the body of the car works, how quickly can the car move? We look at fluid dynamics, which is where my main field was. How do we look at how the particles flow across the body of a Formula One car? So this comes with the same thing as Tesla. Now, as aeronautical engineers, we don't only create designs, we do a lot more as well. Our industry focus, not only focuses on taking people to the sky, or like I said, in designing fast cars, it also focuses on electrical engineering. We've got to know electrical engineering and understand it very well, because without electric circuits, you can't get any of these to move. Without electric circuits, Tesla wouldn't be smart enough to enable its codes to run through to understand what it needs to do in terms of avoiding an accident, for example. Now, on aircraft, we need avionics. Without avionics, you wouldn't be able to tell where your aircraft is in the sky, how fast you're going, how much you need to slow down, or what angle you are in the sky to ensure that you do not go in a situation where you end up in a crash. Now, as aeronautical engineers, we also have to understand mechanical engineering. So mechanical engineering is a huge focus as well, because you need to understand propulsion. You need to understand how your engines work. You need to understand how your jet engines work. You need to understand even how your rotor blade engines work. So all these things all come into place. Now, you also have structures. So as aeronautical engineers, we also do a fair amount of civil engineering because we do not understand how structures work, how materials for structures work. We do not understand the strength of materials. We do not understand whether it's going to cheapen the build of the aircraft. There is no way we can build the whole thing. And there's no way without understanding structures that we can get things to fly. So as part of civil engineering, materials engineering falls into place, sometimes as part of civil, sometimes separately. But as you can see, a lot encompasses aeronautical engineering. Now, the last thing, of course, with aeronautical engineering is computer engineering. So as aeronautical engineers, we need to learn how to code as well. If we do not learn how to code, we will not understand how your pressure systems on an aircraft work. For example, if you needed the aircraft pressure to change based on how high in the air you are flying. Now, this is what we call altitude. And we need to make sure that is in line. We need to make sure we code things up such that we can get the doors open in an emergency. All these things all fall into place. We even need to make sure we can code to have the air conditioning working on the aircraft. So as you can see, aeronautical engineering covers a massive aspect. So we find ourselves in our first year of the degree, sometimes up to year 2 even, doing a lot more things than aeronautical design. We do mechanical engineering, we do civil engineering, we do electrical engineering, we do computer engineering, and then we come into design. So if you're young and you're looking for a degree where you want a bit of challenge and you want to have the flexibility of going to many industries, aeronautical engineering is something that I do encourage. And with the way Elon Musk is doing his research on and getting all of us to space, now surely that's something to inspire you on as well. Now, before I continue, are there any questions for me before we get on to drones, or is everyone okay? Okay, I don't see any questions, so I'm just going to continue. Now, if I'm going too fast as well, please feel free to stop me. So how, yes, you're asking if an e-certificate will be provided. Yes, an e-certificate will be provided at the end of this webinar. There will be a link for you to fill in a form. Once you fill in that form, we will provide you with the e-certificate. Are there any other questions? Okay, great. Now I'm going to continue. Hasina, you'd like me to slow down? Sure, no problem. I'll slow down a little bit more. It's not a problem at all. Okay. Now let's go on to why drones today. So with aeronautical engineering, by the end of our degree and by the time we start in the industry, we have an understanding of aerodynamics, materials for aerospace, structures, propulsion, flight mechanics, stability, and control, which is your avionics. And we find many opportunities to do things. So drones is one aspect of aeronautical engineering that has come up in the industry. Drones are also known as unmanned air vehicles. The short form of it is UAV. It's been popular among us for many things. We use drones for aerial photography, for example, to take wedding photos. That has been quite popular of late. We can also use drones to take images of gas pipelines and farmland. They're also used for military surveillance. Now, many don't realize that drones are vital for infrastructure such as buildings and train tracks. Now, we need to educate people on how this works as well, because people think that drones sometimes are just for fun or drones are for spying. No, there's a lot more that you can use for drones. Now, drones can detect cracks to prevent building collapses. It can prevent train rail derailment as well, okay? Because there's a lot of things that it can find out that the human eye can't even see. Now, the other thing is drones have a lot more time. Drones can work 24 hours a day as long as it's charged up. So as long as the drone gets charged up, goes back to base, finish charging, goes back out to the site, it can do a lot in terms of managing things over manpower. Now, you might say to me now, Jasmine, aren't we supposed to create employment? Yes, we are supposed to create employment as well, but it doesn't mean that if we create drones to look at whether infrastructure is safe or not, we will lose employment. The answer is we will not. The employment will still be there, but the employment just changes. The employment changes to understanding how to fix the drone. The understanding comes in how do you enable the drone to be maintained? How do you make sure the drone is charged up? Where do you put the drone? Where do you get the drone to fly? The work becomes becoming the drone pilot. So the jobs just change. So Hal, you have another question for me in terms of the e-certificate again? I'm just going to type the answer to you now. Okay, so the answer is yes, it will be. A link will be sent at the end of the webinar for you to fill in so as to receive your e-certificate. Will the recording be available? What if you're asking? Yes, the recording will be available and it will be shared at the end of the webinar to all the email addresses as well. So if you wish to receive your e-certificate, that will also be sent across via email with the link to fill in to receive your certificate as well. There will be some questions that we'll ask you in terms of improving the webinar that you will have to fill in first before receiving your e-certificate. No problem, Awatif. Okay, now to continue. So back again, a drone is an unmanned aerial vehicle. It is an aircraft without a human pilot on board. Now, doesn't mean that with drones, there are no human pilots. The human pilots are either on the ground or they are in their center, their office, commanding the drone. So this is where computer engineering is extremely important. Without computer science, we will not even get a drone to fly in the air either. Now, you can get, of course, remote control drones to do simple things like this, but we're talking about much bigger scale drones today on how it can help infrastructure. Now, the flight of UAVs, I'm going to use UAV as a simple term throughout my webinar. UAVs may operate under remote control by pilot, as mentioned, who watches the movement with the UAV or with autopilot. Now, what is autopilot? Autopilot is something that we can set. For example, to get drones to move. Now, we can set drones to move on autopilot. That would be fantastic. Well, that is already. Of course, it's very expensive. But autopilot mode, you can give the drone coordinates and the drone can move across various coordinates, whether it is XYZ on coordinates. What does XYZ coordinates mean? That means you can think of whether it's height-wise, length-wise, breadth-wise, which part alongside a building or a train line do you want it to move? Now, there are also fully autonomous UAVs that fly without any human intervention. So this is similar to your autopilot, but they're extremely smart. So there's a lot of builds in terms of AI for drones these days, where the drone will move accordingly to what it thinks you'll see. So for example, if a drone is in a train tunnel, that's how we hypothetically say train tunnel, and it sees via infrared on the drone's dampness on the train tunnel wall, the drone can be smart enough to follow that dampness and see how far that dampness on the train tunnel wall goes. So this is how smart drones can get these days. Can drones go underwater? The answer, Hasina, is yes. It has been invented. It's actually under research at the moment that drones can go underwater. In fact, we did this as one of our projects under our education center with kids. As part of the global Lego competition, one of it was on design. And the kids at our computer science center did a project on drones that can are hybrid actually. They can go underwater and above water. So in the same logic, Hasina, of how submarines work, imagine it as a much smaller submarine with an underwater camera on board. But the answer is yes, it has been invented. Is it really out in the industry for use? Not quite yet. It's extremely expensive, which is why we're having the topic today. The more people we teach on drone design, the more people we encourage on drone design, it will cheapen the cost of many of these designs as well, making it a lot cheaper for underwater work to be done. Now, underwater drones that are fully autonomous may not totally exist yet, but at this point in time, the extremely expensive ones are able to check for underwater gas pipelines to see if there's any leakage. Okay, so here's the use of drones that I'd like to go through now. So use of drones, we have wedding photography. So that's very popular. You see the pilot there, the guy in green. So he's probably the wedding photographer, but in this situation, he's considered a pilot. Why is he considered a pilot? Because he's piloting the drone to tell the drone where to take the photographs. Drones can be used for medical transport. Now, this is fantastic in particular in areas where there has been, say, a tsunami or an earthquake, a natural disaster has occurred, and they need to quickly bring in medical supplies in, if presuming all the infrastructure is down. So let's presume the roads have been affected by, the disaster. Let's presume the train lines have been affected. Airport has been affected. Helicopters can come in, but helicopters can't go in to very small areas without landing. Helicopters can drop, but helicopters may actually drop in the wrong areas. But so this is where drones come in. From the helicopter, you can get the drone out from the helicopter to send supplies into very exact areas. So that's the beauty of medical drone transport. Now, the next thing also for drones, we have package deliveries. This is Amazon's package delivery, Amazon Prime Air, that delivers packages to people. And this is already in effect. It's not out in Asia, not in ASEAN, especially in particular, but it is available in a couple of developed nations. The US and the UK in particular do hold Amazon Prime Air. And it's interesting because you can just deliver packages down to the doorstep of somebody's house, which makes it a lot easier. So imagine if somebody had to drive out 2 hours to the countryside to deliver a package. The drone would do a much more efficient job. Military combat. Now look at how big this UAV is. You probably can't really see to scale size, but if you look at the mountains, it literally is, they can be the size of a small little plane. That's how big military combat drones are. Military combat drones are able to be loaded with missiles as well. Okay, so extremely powerful military combat drones. Of course, they are also extremely expensive, but in terms of warfare, if you do not want to lose men at all, this is one way that is going. Agriculture. Now, if you look at this drone, see how it's been put 1, 2, they're like 1, 2, 3, 4, 5, well, about 6 sprinklers. Yeah, there's 6 sprinklers below the drone. Now, the sprinklers are not there for water because the drone wouldn't hold enough to hold water, but the drone will hold enough for crop medication. So say if you need anti-pesticide medication on your crops, or basically, you need pesticide on your crops to prevent your crops from getting eaten up, or from any disease even. If your crops are being diseased and you need to give them medication, this is one quick way to cover the whole area much better and much quickly. Right now, what happens is either men manually go in and they sort this out. In countries like US or Australia, where the grounds for agriculture run for hectares, they actually use helicopters to do this. Now, it's great, but it's extremely expensive to run a helicopter to provide medication to your agriculture. So this is where drones come in and to cheapen the cost of that. Now, railway inspection. This is really clever. It's not being done enough, I find, globally. There have been so many derailments, whether it's in South America, happens in developed nations as well, naturally. There was a recent one in Taiwan, quite unfortunate, not necessarily, it it wasn't an exact cause of something that happened on a train track. There was obstruction there. But if we had a drone that could even find obstructions on train tracks in advance, accidents will not happen. Things can be saved. Now, if you look at this particular drone, it's really cute. It's got some yellow bits sticking out like legs. So it can kind of like walk, you would say legs with a bit of wheels at the end. It can kind of walk alongside the track as well. Now you see there's a camera in the middle, and it comes all the way down. The reason why it comes all the way down is because it needs to capture the left and right side of the train track to ensure that there's no cracks in the track. So it ensures that there is no cracks, and it ensures that there's no derailment. So if you can see, if we can get railway inspection drones across all the nations of the world, we could be saving many lives. It could, especially where it's very heavily used in countries where the population is so fast, like India and China. Now, underwater tunnel cracks. This picture that you see here is a photo of Singapore and Singapore's underground train system. And you see all the engineers trying to test a drone underground. Now, up to only a few years ago, up till about 2016, you're going to be surprised, but Singapore's Mass Rapid Transit, we call it our MRT, the inspection was done via manpower and over kilometers and kilometers of underwater tunnels. Now, we are lucky, we're not a big country. You could cycle around Singapore within a day, so that's very lucky. And what would happen is that 4 men, many teams of 4 men, 4 men per team, sometimes a little bit more, they will walk across all the underwater tunnels with a flashlight. In the newer tunnels, at least the lighting is good. They can have the lights on. But in older tunnels, literally, they walk around with a flashlight and they check for whether there's any dampness on the wall. Now, when you see dampness on the wall, that means water has come in from the outside of the tunnel and is starting to leak through, which means that there is a crack. So the minute they see dampness on the wall, they have to escalate and they have to figure out what is going on and where the crack is coming from exactly. Now, this is not so straightforward because as humans, of course, with the human eye, it's not so easy, right? With the human eye, you can miss things. So with a drone, you can actually help to scan across the entire tunnel. And we use infrared technology, IR technology, to check for temperature changes. So if the temperature on one side of the wall is different to another side of the wall, something is wrong. Because if there's dampness, the area of the wall will have a lower temperature. It will be cooler, which means water outside is coming in, because inside the tunnel, it's hot. It's hot. Why? You have electrical circuits running, you have trains running through. Everything inside the tunnel is very hot because it's an enclosed area with, of course, no air conditioning. Now, with infrared, so when you have the temperature of water outside being cooler than the inside of the tunnel, this is how we find out whether there are cracks. The drone will then send a signal back to base. When I mean base, I mean the office where the engineers are sitting, to inform them of what is going on so as to try and manage the situation more quickly. Now, in Japan, for example, how this is done, and Japan has been doing this for a much longer time. In Japan, they use drones plus humans to also check the underwater tunnel. So this is like a 2-eye check to ensure safety. So when it comes to safety, there's never any harm doing both. But at the end of the day, this is where drones can support us humans in terms of ensuring that there's no tunnel collapses, everything works fine, and there are no accidents that can happen. Now, oil gas pipeline inspection. Now, if you see that little drone, and this yellow bit here is an oil or gas pipeline. Now, oil gas pipelines can be overground and underwater. Now, drones are great. Why? Because if you have a drone, you can check whether an oil or gas pipeline has any leakage at all. That a drone will pick it up. Now, oil and gas pipelines run for thousands and thousands of kilometers. You can imagine across Russia, oil and gas pipelines running across Russia, oil and gas pipelines running across the US, oil and gas pipelines running even from Malaysia to Singapore. Now, people don't realize that, but there are pipelines even underneath, where the seabed is between Malaysia and Singapore, moving not only oil and gas, but also electricity to Singapore from Malaysia. So drones are so vital in terms of ensuring that all these work and that there is no situation, because this is the most vital. It can cause explosions, and with serious explosions, if you can imagine, if there's one explosion on oil and gas pipeline, that explosion will run for thousands of kilometers. It can be pretty unstoppable for big explosions. Now, construction safety. Construction safety is where we're going to be concentrating on today as well. With construction safety, this is where your drones can come in. Your drones can come in to see whether your things are built properly, your scaffolding is built properly where your construction workers are climbing on to ensure that they are safe. Drones can ensure that all pre-building checks are done properly. Drones can ensure that things are accident-free on site as well. So if they think part of the structure is falling, the drone can pick that up. Now, if you're wondering how a drone can do that, in this situation, what it can do is take aerial videos and photos non-stop around the entire construction site. So instead of a civil engineer or safety engineer going around and taking videos and checking one by one, your drone can do that, and your drone has the patience and the power to do it for a long time as well. Now, if I'm a safety engineer, I'll be so hot in the hot sun all day, making sure that everything is checked properly. But with a drone, I can have it take lots of pictures and lots of videos for me to watch, in the comfort of my engineering facility, right? And so you don't want to be in a situation where human errors occurs because it's hot, it's humid, it's tiring. Your safety engineer has had too much on checking grounds. Let the drone do the checks, and the safety engineer wouldn't have lost his or her job. The safety engineer still has her job or his job, but from the office instead, in helping him or her to find out what could be wrong. The safety engineer, if he or she finds something that the drone has picked up, can then go and get it fixed as well. Okay, are there any questions for me before we start on the history of drones? Okay, great. If no questions, I'm gonna just continue. Now, we talk about drones, and you may think that drone is a new design. The answer is no. What is a drone? A drone is something that it can just fly on its own, and something that can just fly on its own dates back to 1782. Now, there's been earlier designs by Leonardo da Vinci, which started 538 years ago, though there is no proof that anything was done with that. Now, his design was said to inspire today's helicopters. Now, if you look at the design that I have at the top of the screen here, if you see, there are two rotor blades hanging at the top. Now, rotor blades that spin basically freely at the top of an aircraft is what we call non-fixed wing design. A fixed wing design is something that is fixed to your plane that takes you from Japan to New York. That's called fixed wing design. The wing is fully fixed on the aircraft. With rotor blade design, it is not the case. So if you look at your drones, if you see all of them have rotor blades hanging out here at the top. If you look at the one for medical transport, that's a good example. You see 4 rotor blades, or if you look at the one for construction and safety, you see 4 white rotor blades that spin around to make the drone fly. This is what we call something similar to helicopter design, okay? So in the same notion, fixed wing, if anything fixed wing, if you look at the aircraft that you see here on this image on the bottom right, you notice that the wing is fixed to the aircraft. The wing doesn't spin around. This is what we call fixed wing aircraft. So anyway, back to the history. Formally, history of UAVs began when Etienne and Joseph Montgolfier lifted a balloon filled with smoke into the air with a basket attached to the ball. Now, this is your design for the hot air balloon. Of course, they didn't dare to go in themselves, plus it wasn't that big. So they put a ram, a duck, and a rooster, and they all went in. And they flew. They flew for 8 minutes across 4 kilometers. That's very good. Now, although balloons today do not belong to the group of drones anymore, their concept played a large role in the history of aviation. Now, how did it play a large role in aviation? It taught the Wright brothers in particular how airflow helps lift things up from ground. Now, how do you design something to make the air lift something under a wing up from the ground? This was the vital bit in this design. This is 1782. Your first battle drone came in 1849. And this was when the Austrians attacked Venice with unmanned balloons filled with explosives fired from a battleship. So in this case, it's similar again to the hot air balloon design. But why is it called a drone? Anything that can fly on its own without a human pilot on board is called a drone. 1917 Curtiss M9. This is the unmanned vehicle that you see on the image here at the bottom right. Now, this was done in the US. It was American engineers, and they transformed the US Navy training aircraft into the first radio-controlled UAV. So using radio controls, it got the UAV to fly. It flew 50 miles with a 300-pound bomb. My goodness, this is 1970 during World War I, but it never participated in actual combat. Now, present-day drone design. Look inside here. Now, this design comes from DJI. DJI is a Chinese manufacturer of drones. Now, DJI is, they do a lot of things apart from drone as well. They even create gimbals. Gimbals are things where you use for photography, where you can, manage the stability of you taking videos outdoors or even at home, really. Now, look at DJI. I'm using DJI as an example because DJI is affordable in terms of drone pricing. There are many kinds of DJIs. It's much smaller ones, of course, but they work. They have extremely good camera. Now, I'm going to start a little bit differently. Since I brought up the gimbal, you see the bottom, you see the 3-axis gimbal and the drone camera. The gimbal is what enables stability of your camera. So as a safety engineer, if I want to see whether my construction site is safe, I do not want to be in a situation where I'm getting images that bounce up and down, blur, and I'm blur. So the only way to enable stable design and stable camera taking is this 3-axis gimbal. You're wondering what 3-axis is? In aeronautical engineering, we call it roll, pitch, and yaw. I can go into more details on that in the Q&A if you'd like me to. So we look at 3-axes when we are designing aircraft or any kind of aeronautical design, including drones, and in this case, even for simple things like the camera. Now, this helps to decide stability of the camera function, and that's where the gimbal comes in, which is how DJI has started creating gimbals for your iPhone even. Now, if you look just above that, I'm going to look at the downward sensor. So if you notice, downward ultrasonic sensor, downward obstacle avoidance sensor. Okay, so the main thing of these is, in particular, the obstacle sensor is that if it comes too near something, it will alert the drone to fly away from it. So if it senses an obstacle, it flies away. Okay, now this is really interesting because if you are ever interested, if any of you play Lego, now in Lego engineering, even teaching Lego robotics to kids, this is something that is taught as well. And we don't realize this. There are simple things that we learn, even things that we play with, any toys we play with, simple things that we play with. A lot of them have been built in with so much that encompasses modern day engineering and how it even is used in industry. And these are just more of the simple things. So when our kids at Education Center learn about obstacle design, they only think like, oh, okay, maybe I use that because I do not want a car to hit something. No, it's a lot more than that. It comes into drones. It comes into all sorts of unmanned aerial vehicles. It comes into all sorts of engineering design. So that's extremely vital. Now, with that, are there any questions before I continue as well? Okay, now it works alongside the, no questions, so I'll just continue. So it works alongside the ultrasonic sensor. Now, ultrasonic sensors do the same thing. It goes alongside obstacle sensor in terms of being able to measure the distance of an object that it wants to see. So say, for example, you in particular say to the drone, okay, the distance between you and the gas pipeline has to be 200 meters. This is where the downward ultrasonic sensor senses that distance. Now moving up, you have your power port. So power port naturally it's like the battery, of course, of your drone, but this is chargeable. The drone has to go back to base to get charged. Your electronic speed controller, we call it ESC. Now, what is your electronic speed controller for? Electronic speed control controls the speed of your drone. You can set it to run at a particular speed before it flies. You can set it to fly at a range of speed as well. So if you say to the drone, you can only go between a range of 10 kilometers per hour and 20 kilometers per hour. This is where your ESC steps in. Another one, forward optical avoidance sensor. Now that's the same logic as the downward obstacle avoidance sensor, just that because your drone flies up and down, left and right, forward and back, you have forward obstacle sensors around it as well. Now, the next thing would be your in-flight LED, just gives it some lights on the drone so that if it is late at night and you're trying to figure out where your drone is, your LED will show you where your drone is if you're pilot from the ground. Now, what is your GPS? Your GPS is to tell you where your drone is. So where is your drone on the map? And you will have, as an engineer, on the map to see a map on screen at your base, your engineering, or in your office to see where your drone is. So this is where the GPS module comes in. And then the top bit. So you have the drone motor and you have the drone propeller. So back again, your drone motor is what drives your drone propeller. Your drone propeller is in effect the wing, or in this case, your rotor blade of your drone. So you see, it's very straightforward. If you go to the dji.com website, you have lots more information on this as well. But this is a very simple example of a present day drone design. Are there any questions for me? Okay. Okay, there are no questions. Let's move on. So how do drones work? From start to finish in minutes. A drone can autonomously survey and run inspections on a location, land back at its launch location, and upload its model and data being any footage in terms of temperature that it may have sensed, any footage in terms of photos or videos, to the secure cloud. Secure cloud would mean no different to, for example, your Amazon Web Cloud, your Microsoft Cloud, your Google Cloud, all to you so that you as the engineer will be able to see what's going on in a matter of minutes. So things have moved very quickly. All you need is a launch location. So where's your drone going to launch from? You can launch from like a launch pad. Okay. And what else do you need? You need, this is being open-ended, but you also need where you want your drone to go. So you need to set the GPS modules where you want your drone to go and take pictures of. And then at the end of the day, you need a computer to be able to have your drone send data to the cloud for you to be able to view it. Now, in specific, hi Suhal, the link for the e-certificate will only be sent at the end of the webinar. I'll type it out for you. Okay. Now, use of drones for SDG 9. So we're going to be a bit more detailed into what we had talked about before. Use of drones for SDG Goal 9. So in oil and gas pipelines inspection, the issues with inspection, pipelines transporting oil and gas around the world span thousands of miles. Pipelines can be in remote mountainous locations or even in deep water and Arctic environments. Now, in mountainous locations or in places like, the South Pole, for example, inspections are still necessary despite extreme weather conditions. So it's not to say that we do not need to inspect when it's snowing or there's heavy rain or there's a monsoon. Things still go on. Now, human inspection results in potential exposure as well to hazardous chemicals. So in the case of oil and gas pipeline inspection, you don't want a situation where you have a person going and check all the pipelines unless they're very prepared to do so, in terms of being able to wear the right clothing in case of any leakage. Now, this is where drones come in to find where the leakage is and have the drone inspector go in only when he's absolutely ready. Now, the advantages for drones for inspection in terms of oil and gas pipelines: using specialized thermal sensors, drones can find oil leaks by picking up temperature differences. So this is similar to my explanation in terms of the underground tunnel. The only difference here is that it finds the temperature difference between the fluid and the soil. And drones can do it a lot faster than a human inspector as well, because the drone doesn't have to walk. The drone just flies and in very close proximity to the pipeline. Now, with highly sensitive optical sensors, drones can monitor gas emissions over critical sites as well, and large areas that they are otherwise unable to cover. So sensors are key. Now, sensors are very key in terms of drone design. The more sensors you can put onto a drone to fit what you need to do, the better it is. Now, the next thing is the high resolution cameras. So with cameras that are so powerful these days and getting smaller and smaller and lighter, cameras enable us to diagnose the issue remotely. So from my computer as an engineer, if I'm in my office and my drone is flying outside, I know what is wrong immediately and I can plan straight away. I do not have to run back to my office. I'm already in my office and I can plan to execute what we need to in terms of, when can we plan this to go down to have it fixed? Do we have to do it immediately or, can it wait? So how the duration of this webinar is about over 2 hours long. It really depends. Depends on how much Q&A we get as well. The more question and answers we get, the longer the webinar will run for. So if there are people that do have questions, we will extend it. Now, next, infrastructure, underground railway tunnels. So again, I have brought this up before, but just to recap, underground railway tunnels in one country can span hundreds of kilometers. Inspectors up to 3 at a time per tunnel segment are required, or 4 even, like I mentioned before, are required to walk through the tunnels in the middle of the night when the trains are not operating in search of water leakages, or rather dampness on the wall. Lighting is poor in the tunnels, resulting in inaccurate inspections when only torchlights are used. So only in the newer tunnels are they brightly lit, but they have to cater to tunnels that are much older as well. And these do exist everywhere. The advantages of drone inspection. Now, using specialized thermal sensors, drones can find water leaks by picking up temperature differences between different tunnel and segments. Drone can use high-intensity LED lighting and high-resolution cameras to capture videos on the leakages for remote diagnosis. This reduces costs and increases efficiency of fixing the leakage, hence preventing unnecessary train line closures. Now, this happens quite frequently. Like say if an inspector catches something a little bit too late and they can't plan for the leakage to be fixed properly, they might have to shut the whole train line tunnel even during rush hours. Now, I guess now we work from home, this is not really an issue, but imagine when the pandemic is over and we all need to go to the office and the train lines are closed. This is extremely big problem in many countries that run a very heavy train line system or heavy commute on train lines. Now, for railway derailment, so this is another way for infrastructure that drones are used. Railway tracks across countries span thousands of kilometers. Australia, for example, has 40,000 kilometers of track. Current railway track inspections are costly and involve the use of dedicated vehicles that require a train path to operate. They can also involve dangerous practices in remote areas. So if you imagine very mountainous areas and you get a human to go and walk around the mountainous areas, it's extremely dangerous, right? So with drones, that takes, ensures the safety of our inspectors. The inspectors can do it from the inspection from the office and go in only when necessary with the right equipment and the right safety gear. Now, the advantages of autonomous track inspection. Now, this is great, right? Because ground robots are still used for remote inspection. When we get drones, they don't have any issues or difficult terrain or limited mobility, so that they will be able to move whenever they need to move with a drone because they can just fly. Now, the unfortunate thing is, as I had mentioned much earlier at the start of this webinar, in underdeveloped countries, there are not enough resources provided for inspection, which means there are not enough people that can track train lines of 40,000 kilometers, for example. It's too vast. Now, even if we spend people working across, they just can't be walking kilometers and kilometers per day, even within their own section of the country. It's extremely tiring. So hence why many people do not want to do such work, and hence why there are not enough resources for this at all. And this is where drones can come in to ensure the safety in underdeveloped nations. Now, if we can get drones used for railways in many underdeveloped nations, a lot of accidents can be prevented. Not only that, if we can get drones to be cheaper, underdeveloped nations will find it much easier and less costly to use it in their own countries as well. Now, one more, infrastructure and collapse of infrastructure. How great are drones used for this? In the event of hurricanes and earthquakes and the aftermath of it, you'll find that there's a lot of collapse of infrastructure, such as roads, bridges, buildings, and such infrastructure is vital in assessing damage, evacuating victims, medical aid, and of course a helicopter, like I said before, can come in, but a helicopter can go where critical damage is. It's where a drone can quickly go in to assess the damage. It can see where the bulk of the victims are or stranded victims are, to ask the helicopter to go to based on its coordinates using GPS, save the victims. It can also deliver medical aid and food supplies to areas where the helicopter still cannot go in yet to save victims. Because if you can imagine, the helicopter has to pick people up from somewhere, and it has to be at a height near enough for them to lift people up, whether it's through a rope evacuation. If it has a rooftop to land to, the rooftop may not be safe enough for the helicopter. So the beauty of your drone is it can check all these things before the helicopters come in. So just to recap, the drones have been able to fulfill all these goals in disaster relief and now, top 10 drones for disaster relief management, outstandingdrone.com for top disaster relief management drones. And you can have a look at it after this webinar as well. But this is also very interesting if you want to understand more about drones. Now, something a little bit more different here. We're going to talk about planning and management for construction. Now, this sounds like a very heavy topic, but let me go through it and how it works. If you see this image here, you see that this is a construction site, but there are no buildings yet. Okay. Now, what happens normally is a land surveyor go in to monitor any surrounding buildings around the existing construction site. If there's a building there already that they're looking to knock down, it can also track how it is. It can gauge topography and soil type. So they're going to look at how the land is, which part of the land is soft, which part of the land is harder. Are there any issues in the land that can cause if it's sloping, will construction cause mini landslides, for example, along sloping ground? So topography, which is the study of all forms and features of the land surfaces, this is it exactly, because you need to ensure that it's safe. You cannot have a situation of a mini landslide of a bit of a land sinking into the ground when your engineers are there. Okay, it will be a very major accident. So software developers have created solutions that analyze the construction progress with regularly captured data. So this is great. that has been created. But of course, something needs to go in to capture such data, and these are drones. So very critical as part of this whole process is software development and drone development. So why do we use drones to map areas and check for soil and check for safety? And this not only needs to be checked at the start of the project, it has to be checked throughout the project. So even around the building as it's getting built, or even in areas inside, it has to check that everything is safe as well. So land surveying is long hours, and there's a lot of heavy equipment that your land surveyor has to carry as well. So instead of this being done over days, which can also be risky because something may not be picked up in time, drone mapping can take minutes to complete an entire site survey with the same amount of accuracy. Again, it doesn't mean that your surveyor is out of work. It just means that your surveyor's job has changed. It's just less outdoors. Your surveyor is kept safer, regardless of weather. There are no dangers due to unexpected terrain or accidents with the heavy equipment drone is doing that work. And what else? The surveyor can see if it has to go into this terrain where a danger may happen. The surveyor can find ways to make sure he or she is protected before going in, be it getting additional support or getting particular clothing on in some instances. Now, all this with drone mapping, it makes it possible. It brings down the cost. A traditional land survey team can even take a month to map a dangerous 100-acre site. A drone doing aerial mapping, it can extend within 1 hour. So you can see it's a lot quicker. Now, to add, this allows construction companies to complete more jobs in less time. So if construction companies can do more jobs in less time, your construction company can move on to another job, hence increasing revenue. So in underdeveloped nations, this is also something that's rarely used, and we want to encourage the use of this in underdeveloped nations. And why would I like to emphasize on this? In underdeveloped nations, this is where countries are building up even more. They're building more buildings because they're going to be developing. And they're going to be building more buildings, and they need more help to ensure that everything is fine in terms of their construction. We do not want buildings collapsing because they're rushing to improve their economy, they're rushing to build. So it's all part of a life cycle of building. I have a question. Art Clarino, very interesting in using drone for aerial mapping. On the other hand, how about privacy issues? Yes. So drones, I'm going to talk about a bit of that later, but this is where the law comes in. Now, in many countries, for example, I'll give Singapore as one example. If you want to use a drone to do this, they have to ensure that your use of the drone is within a certain part of the island. So you cannot go out what you call a particular area. So you say, I want this drone used in this area, and it will span X kilometers north, south, east, or west based on this postal code. You are allowed to use it. If you move your drone out of this area, it would be considered illegal as you do not have that license to do so. So in many countries, you can enforce licensing controls such that if it goes out of bounds, it can sometimes be a criminal offense. I don't know if you know, for example, in the UK, there was an incident a few Christmases ago where a drone ended up at one of the airports in the United Kingdom, and it shut the whole airport down because with a drone there, it can cause an accident when the plane takes off. So that is a criminal offense and it's subject to a potential jail term. When I mean criminal offense, I mean that you can go to jail for doing something incorrect with your drone. Now, other privacy issues are, for example, in Singapore, for example, and in the UK as well, you're not allowed to be X kilometers near any airports. You're not allowed to be X kilometers near any military grounds. That is the law there. So on the map of each country, there can be places where you put no fly zone area. So a non-fly zone area for a drone can be established for every single country. So as long as this is established, you can impose fines in some circumstances. Like if it's not so serious, you impose a fine. If there can be a serious breach of privacy, you can impose and make it an offense as well. okay, I guess, sorry, criminal offense is not the right word to use, but it is an offense by law. The other way that you can see it as well is if the drone flies along a residential building or office building, that can be considered illegal too. So that's one way of doing it too. You ensure that the drone does not go around that building. So this will ensure privacy as well, because I think the main thing is you do not want drones near any government sites, military sites, residential sites, and commercial sites where people are in there. That will not be allowed. I hope this answers your question. Now, for construction safety, so drones can monitor construction sites, especially spread out over several locations, so not just one building. There is a lot to monitor in terms of the safety of a construction site. Now, for example, in Indonesia, where the country is so vast, there are areas where they're building entire communities, buildings to hold entire community. Now, this is where drones can help out to ensure the safety of these entire construction sites. Now, drones can be equipped with infrared cameras, radars, and other technologies you have seen that enhances their surveillance capabilities. This information is useful for tracking not only construction progress, but also monitor the safety of workers, equipment, and material on a job site. If a scaffolding is not built properly, where your construction worker has to stand on, or even a scaffolding lift is not built properly, this is where your drone can come in and make sure the scaffoldings are built safely. If there is a situation where falling equipment could happen in a particular construction site, your drone can pick it up as well. So say, for example, there was some equipment on the rooftop, and for any reason overnight, there was extremely heavy rain and wind, and some equipment had been moved. Now, before your construction workers come in, your drone can go in and inspect where all the equipment are to ensure that they're still in a safe location. So sending real-time footage of these site conditions to protect its project managers and construction workers are key for the use of drones for construction safety. Now, we're going to go into case studies very soon. Is there any questions? Okay, I'm going to continue with a few case studies. Now, infrastructure. So we talked about infrastructure earlier and construction safety and debris falling from a construction site. Now, this can also happen even in buildings that are fully built. There was a case in New York City that had been pushing to legalize the use of drills for building facade inspections after an architect was killed by falling debris from a building in the city. There was some work being done on top of the building. This was, work not being construction, but just very minor works, and something fell, and it was very unfortunate. It hit someone. Now, in this situation, so this is where the concept of privacy comes in. This has not been legally approved because there is an issue of having the drones go floor by floor and check, and it is a privacy issue with corporates in there. Now, this hasn't been approved, but there is a call for it. So it is still currently illegal to fly the drone in the city, but if approved, the proposed bill will allow the drone to speed up the inspection of buildings and improve the safety of people in the city. So it's very debatable about this topic in terms of privacy as well, but we'll just never know. Some people can be extremely uncomfortable with it. Some people are not. I'm sure the family of the architect who was killed would be very comfortable with this happening. But of course, many of us may not be. Now, construction safety. This is one very interesting case that if drone design was something big in 2004, maybe a few things might have been helped with. Jonetti, sorry, you raised your hand. Can I help you with anything? You can type it in the Q&A if you like to. Yeah, feel free to type in the Q&A and then I'll respond to you. Now, there were inadequate temporary works and design and construction errors, which led to the fatal collapse of one of Singapore's deepest ever cut tunnel. So if you see here, do you see this channel here that's being cut, this big round circle here? So there was a collapse and it hit 110-meter section of the tunnel, which was being constructed for a new underground train line, which we have in existence right now. So we have a highway in Singapore that collapsed due to this, because this highway was, well, the motor highway or car highway was just next to where the construction for this cover tunnel was being built. 4 workers had died in this construction, which could have been easily prevented. So what could we have done to prevent this? We could have had frequent inspection of the construction site using drones. So you can see it's a huge site, hard, to manage. The construction workers were under very tight deadlines. But if drones could have come in at this point in time, of which drones were not popular then, people's lives could have been saved. So if you look at this, this is the collapse. If you can see here, so this was where this tunnel is, and this is where this big hole gap is. And can you see here that the entire thing caved in just before it? And then this is on the left here is this highway, and the whole thing collapsed. Now, what was interesting is that my mother used to take this highway every day that year. She used to go and pick up my niece, and she had to travel past this highway to pick up my niece, to care for her. And just that morning, she had gone a lot earlier and missed this entire collapse. So for things that are close to heart, and you think of it this way, you really want much better inspections. Of course, things have changed now, and the safety has also changed in a lot of these places. We increase inspections using drones too. So if you look at the bird's view of this is one of the bird's view here of how it was and how it was fine. And this is the entire collapse, bringing the bridge down on its left as well. Now, research and development. It's quite interesting. So if you ask me about any new research that has been coming in for drone development, a Swiss university has started partnering with architects to form a team, creating a structure to build entire UAVs. Now, the bricks that you see this UAV lifting here, they're polymer bricks. They're not actual building bricks. It's very heavy because building bricks are, at this point in time, it's not cost effective at this point in time to use drones, but things will change. And I'm sure we can find ways for drones to carry much heavier bricks to form and build buildings in the long run. Of course, there are concerns at this point in time in terms of safety issues, but again, we can use drones to help with the safety. But at the end of the day, it's really interesting to see universities look at such design. Now, more research were needed. Let's call for more research in drone development. Now, why? To increase competitiveness and hence reduce costs of manufacturing drones. We want to reduce manufacturing costs, the cost to purchase, so that developed nations can come in and buy these drones to use and maintain the drones. Now, this will only cheapen the cost of the drones if we can get more ideas in and more manufacturers to do it. And then lastly, to find more social impact solutions. Now, what do I mean by find more social impact solutions? There's so many sustainable development goals. We are thinking of drone in one way now, which is in terms of drones for goal 9, but how can drones also be used for many other goals? So that's something we can think about as well. Now, I'd love to think of more reasons together. I'm going to give 5 minutes for anybody to come in on the Q&A and think of any more reasons of how we can use more research in drone development. Anybody think of why? Please feel free to put down in the Q&A. Okay, if there's no reasons that anybody can think of now, maybe that's something you can have a think when we're done with this webinar. Now, estimated commercial drone spending. Regardless of sectors, countries across the globe are pouring investment into UAVs. Now, the hope is that it can bring revolutionary change across industries. So if you look at the countries who is on top of the world in terms of drone spending, you have the USA at 12 billion. So you can see how the USA views it. Of course, a lot of the spending is also in terms of military design. So if you look at all your big powers of the world, there is spending on drones for military use as well. But having said that, it doesn't mean that potentially it is a wrong thing, because if there's research and development in drone design for military, it doesn't mean that we can't use some of that research for everyday design as well. They might figure something out that can make drone design a lot easier for us in terms of railway inspection or in terms of tunnel inspection, or many other ways drones can be used for medical too. So developing countries need to start making the investment too, so it can cheapen the cost associated with infrastructure and construction in the long run. Now, developing countries can consider it as part of their university too. I know it gets hard for developing countries to spend money on research, but sometimes as part of universities, it can also be done as part of project work or thesis for their university degrees or postgraduate degrees. All these can be done by students as well. So don't underestimate the power of students too. Okay, so yeah, we'd love to see this change naturally, and we'd love to see how it can help all of the Asia Pacific as well. Now, the law. I talk about UK government drone laws right now, just for some, because it's been around for long enough, so it's very established. So drones over 250 grams will have to be formally registered, so there are rules on that. Drone pilots will have to sit a safety awareness allowed to fly. So even though they're flying, you're flying from the ground, the pilots will have to ensure that the drone does not hit anybody. So the pilot has to be trained as well. Okay, whether the pilot needs training as an autopilot from his computer to get the drone working, or whether the pilot has to learn how to use a drone remote control better. A safety awareness test is extremely key, that the drone does not hurt anyone. A drone can hurt a young child, the rotor blade can hit a young child, a lot of things can happen. Now, the police have powers to ground drones if suspected of a criminal activity or unsafe flying. They will then be able to seize the drone parts for evidence. Okay. So if the drone is used for criminal activity, it naturally becomes a criminal offense. Now, if you use the drone to move drugs, for example, unprohibited drugs, it becomes a criminal offense. Drone pilots will have to be able to present the registration documents if requested by the police. So that's key. Drone pilots will have to use apps to ensure their planned flights are safe and legal. So they have to understand the area where they plan to fly the drone very well. Restricted areas will be easier for pilots to view, such as schools and military bases. So these are areas that are a no-go zone. So zones where you have a lot of residential, a lot of commercial buildings, schools, military bases, military land, military training grounds, airports, shipyards, all considered no-go zones. Drones may be completely banned from flying near airports or over 400 feet. Now, in Singapore, it is not a maybe, it is a complete ban to fly over, and not only is it a complete ban to fly over, it is a complete ban to fly X number of kilometers in a radius around the airport. Now, I love to interact, but I do see everybody seems a little bit shy. So maybe just something to think about. You are free to type it in Q&A, but if you do not wish to interact during this webinar, you can have a think about it. How else would you like to see drones impacting our society positively? Have a think about that. One way that I can see it is I can see it in potentially keeping certain forest areas safe, like having drones go around all the forest areas more frequently to prevent forest fires. I can see drones being used to help police in finding missing children in certain forest areas too. Or, tracking certain things in terms of safety for kids along the aspect. There are many ways they can impact our society very positively, not just for infrastructure. Are there other man-made disasters apart from the case study in highway collapse today where you think a drone could have prevented it from occurring? Offhand, I can already think of a few like railway accidents in countries that were caused by derailment. There have been very serious ones in South America, for example, the past 2 decades. This is where drones can come in to prevent railway derailment. And the third question is, what type of engineers are needed for drone innovation and design? Now, you need your software engineer to come up with the codes to make your drone fly autonomously. You need your aeronautical engineer to come up with the design. You need electrical engineers to come help in and, come in and decide on the design for even things like your camera, even things like getting your drone to move or to talk to different infrared sensors. That's when it's very helpful. Can a drone do a structural damage to a plane if it gets too near, and can a drone fly higher than a plane? Well, the answer right now is depending on the drone. Some of the military drones can fly higher than planes, the very big ones, they are able to. They can go up extremely high altitudes as well. In a similar fashion, if you want to think about how high drones can fly, in outer space, for example, robots are kind of used to launch, fly and launch certain areas. That's quite similar. I wouldn't call it a drone, but that's quite similar aeronautical feat. The other thing is, can a drone destroy a plane? The answer is yes. A drone can destroy a plane in terms of, for example, how birds do. That same topic, there is such a thing called bird strike, where birds go too near the propeller of the plane. For some reason, birds can be quite attracted to engines of aircraft. Now, when a bird gets trapped inside a plane or the propeller blades of a plane, it gets choked and that whole engine can go down. So in that similar fashion, if you can imagine, if a drone goes too near an aircraft, which is why they're not allowed near the airports, and it gets stuck in the propeller blades of your engine will get choked and your engine will fail to perform. Well, it would just get totally shut down basically. So that's where it can hurt people, and this is where people can die as well. So how the webinar is due to last approximately it was due to last approximately 2 or 3 hours depending on Q&A, but we shall see when it will end based on our interactive tasks as well. Thank you for your question. Are there any other answers? Questions, sorry. Okay, are there any other engineers needed for drone innovation and design? You can also say that in certain cases, chemical engineers can get involved as well. So let's say we're looking at loading up chemicals on your drone, and we need to load up chemicals for your drone to provide in certain cases, stop a leakage, or in certain cases, help with agriculture. This is where it comes in to decide whether the chemical is safe to fly with the drone. Is it protected well? Are the materials encasing the chemicals protected well? And will it provide safety when the drone flies above ground? Okay, so I've kind of done Q&A, I guess, but I'll just wait 30 seconds to see if there's any other questions. Okay, there are no other questions, so I'm just gonna continue on to oh, Hasina, there's a question. Sorry, has screening been activated in drones? Hasina, what kind of screening are you referring to? Could you perhaps elaborate for me a little bit more? What do you mean screening? Do you mean temperature screening or particular type of photography? Please feel free to type in the Q&A. Oh, you mean for COVID that can help doctors? Not that I'm aware of, on whether screening has been activated in drones. I guess at the moment, screening for COVID can only be done invasively, which means, you know, putting out a swab test up the nose. So what drones probably, well, it can that already can be done, which is drones can carry all the swab tests to rural areas. So if you can imagine, in a lot of rural areas, out in India and China, Philippines, or even Indonesia that we can't get to, definitely, your medical transport drones can help move all these screening equipment to be used. Now, the only thing is that what has to be done is the people have to be educated to understand what to do after screening, because they are going to need to be able to test. So the screen test or the swab test will have to go back to the hospital to get tested, or the clinics to get tested. So the answer is yes, of course. There can be pickup and drop offs being done, and I'm sure maybe we can talk about it more on forums, or even share it more that it should be done. But if it hasn't been done, I think it's a fantastic idea, Hasina. But this is one great idea as well, and this is the kind of ideas that we like to see too. So it's great that you thought of it. Thank you so much. Okay, if there's no more Q&A, and you still like to reach me via Q&A, you're welcome to do so. You're welcome to do so, by emailing me on support@lovesback.com. The email address is support at lovesback, lovesback.com. So if you have any other questions on drones, or you want to understand more about aeronautical engineering, or you want to learn more about the SDG goals, and you want to understand more about Goal 9, please feel free to email me. There, it's support@lovespec.com. Now, additional learning resources. Now, I'm not going to let you go away without some free learning. Now, to increase your knowledge, there are a few places that you can go to, which is what is a drone? Galactic Public Archives is a YouTube for it. You may scan through this during the recording that we're going to send to all of you, so you can forward on the recording and take bits that you want. For example, drones reporting to work by Goldman Sachs. This is a great article. I love it. I was still working for Goldman Sachs when they released this article, and I think it's just fantastic on how drones can drive technology and innovation, and it's definitely worth a read. Introduction to Drones, Ellison.com does an introduction to drones, very interesting introduction that you can take a look at. And on a question on drones that are much bigger than they can fly higher than our normal aircraft, this is a great one on the big drone. So this is fixed wing UAV introduction. Aeroworks production, he does look at all the big fixed wing drones, not as big as military aircraft, but big enough even for some people to have it in their backyard in the US. So that is very interesting. I'd love to encourage you to look at that. And lastly, we've come to the end of this webinar. And before we go, I'd like to encourage you to come on board the next training that we have in partnership with UNESCO on sustainable goals. This is on Sustainable Goal 17, and this is happening on Thursday. Now, Wi-Fi needs to run smoothly, just like electricity and water. This is something very interesting. And I was in Jakarta once, and during a speech, ex-President Habibie's son was saying, there should be electricity. Wi-Fi should run like electricity and water for all schools. And this is so true. And this should be something that has to go across all houses as well. One of my ex-Python students had won an award with the Asian Development Bank. She had found out that to promote financial independence for women while staying at home, and especially during the COVID-19 pandemic, they need Wi-Fi. Now, a lot of mothers who are full-time mothers do not have the capabilities of going out to find employment, especially during COVID-19, they are unable to now. But how can we achieve employment at home? Now, if women, mothers have Wi-Fi, they can be caregivers to their family at home. They can be the primary caregivers, but they can also find some employment. Employment being they can share a skill they have online and earn some money. They can share a skill on YouTube, and create a following. Wi-Fi can also help us learn a lot of things. With Wi-Fi, we're able to do this webinar. You're able to learn from home. You're able to learn something new from home. So it's a very important digital tool. And of course, most of you on the webinar today, most of you understand Wi-Fi and how it works. This is a webinar for you to come on, for you to teach your community that do not understand digital literacy on how to use the Wi-Fi. How do you set up the Wi-Fi? How do you use a computer? You can get your mother to join. You can get your grandmother to join. You can get your grandfather to join even. So this is the idea of training on goal 17. Digital tools are very key. Not only on empowerment for women from home, for girls as well. If they start young, they will understand what they will need to do as well when they're older. They'll be more empowered to use the internet. They'll be more empowered to find ways to either borrow a computer or use it at the library to become digitally literate. So you may register here. The link is bit.ly/3ILQD capital D5. We will be sending a reminder out again at some point today to register for this webinar. So please do so. We strongly encourage it. We have a question from Bima. I want to ask something about your opinion. Do drones have a negative side in our life? I think that saying is similar to, does technology have a negative side in our lives? I think in the same way, like how many people are scared of technology and scared of artificial intelligence, there are its good and bad sides to it. Anything that is new and that is being used widely in recent years does tend to scare a lot of people. One example is, with technology, people can say, if there's too much screen time, it's bad for the eyes. So that's a bad side of technology, right? So there always has to be a check and balance in place for using any new engineering feat or any sort of new design. So if you ask me, do drones have negative impacts? Yes, they potentially can, which I do like. It was brought up earlier from one of our attendees. It can have privacy issues, so that is negative. So this is where laws have to be in place to prevent these privacy issues. I can't think of anything negative other than this at the moment. But Bima, one thing also that I'd like to share that's quite, before the world wars, for example, and things like the refrigerator, or I said the radio, for example, that's really interesting. The radios have come up, and people were uncomfortable with the radio when it was first invented. So what people were saying about the radio is, we have a radio sitting in our house, we won't talk to each other anymore. We'll only listen to the radio. So similarly, like how some families feel about their children using screen time too much, in the same logic, there can be a situation as well where, people can feel like, drones have this privacy issue, so we shouldn't use it. So there's always there can be small fears among society in terms of, how to manage this, but slowly we'll learn to live with it as well. But this is a great question. Thank you very much for your question. Can drones actually talk to us, or do we still have to invent that? Oh, that's interesting. Um, I wouldn't say the drones can literally talk to us right now, but right now drones can be equipped with radio controllers to send messages to someone. But the thing is that our drones fly so far these days that is, it just may not, the frequency, the radio frequency, like a walkie-talkie, may not reach the location of the drone to talk to someone. But the fact is, it can be done in a similar fashion, like how your walkie-talkie works. So you imagine if your drone is fit with a walkie-talkie, and your drone goes and sends a message to another friend of yours that is maybe sitting in a park or somewhere. That would be quite fun, isn't it? Yeah, but then again, because drones fly so far, that gets a little bit harder at this point in time. It doesn't mean we can't do it. I think that's amazing if it can be done. We can use artificial intelligence or a chatbot on a drone, couldn't we? It could be done. Chatbots already exist. Artificial intelligence exists. If the drone is fitted with a much better computer, that is definitely doable. So I like that idea. I would even love to look at it myself because I have a keen interest in this topic, as you can imagine. So thank you, Hasina, for your questions. That's fantastic. Okay, I'm gonna share the link for the certificate now. So Hal, this is it. So please fill in this form. If everybody can just go in now to bit.ly/ecgoal9, and you can start filling in this form here. And after you fill in the form, you will receive a certificate of attendance. I'm still here for any questions. We will keep this live for a while more for any questions. And before we go, so please feel free to drop any questions to me on the chat room. Okay, everyone, thank you for joining. Thank you. I'll stay here for any questions for about the next 10 minutes, just in case you need me here. But if not, feel free to go after you finish filling in the form via this link. Keep this link on for another 10 minutes as well. To those of you that are leaving first, I'd like to thank you for joining us today and for being a part of our training in collaboration with UNESCO and supported by UNESCO for development goals. I'd like for you to have a read of the UN Sustainable Development Goals. That'd be great, for you to have an understanding of how we can help our society. And thank you once again for joining our call. Thank you. I'll leave this webinar on for the next 10 minutes. Okay, everyone, I'm going to close the webinar room. Again, thank you for joining. For any questions, if you need post the webinar, please feel free to reach out to me at support@lovespec.com. Wishing everybody a great journey in terms of learning about sustainable development goals and drones, and all the best as well. This is me. My name is Jasmine, and I'm from Empire Code and Empire Code Love Spec. And I wish you all the best in your learning journey. Thank you. Goodbye.